So my name is Ryan. I am an ecological economist at the Delta Institute. We're based in downtown Chicago, and we work throughout the Great Lakes region. But in my greenhouse gas initiatives, I often find myself talking to a lot of scientists and policy folks and such from around the country and increasingly from around the world. So biochar has been one of those areas of interest for me. I've been tracking developments in the biochar protocol space for greenhouse gas since about 2010, 2009. So I'm going to go through a few different things here. So it's mostly going to be talking about greenhouse gas credit registry protocols in the voluntary space. There's really nothing happening in the regulatory side. And then I'll touch on some water quality stuff at the end. So to start off here, this is an image that I pulled from the International Biochar Initiative website. And basically, they're saying biochar can do everything. We've all heard that. You know, the Winfinity, that's it. But for greenhouse gas markets, some may think that it's a reductionist approach. You know, you're just trying to look at how can we maximize CO2 sequestration or avoidance of methane or nitrous oxide emissions. And in water quality, you just look at nitrogen loss reductions or phosphorus loss reductions. And so really that's what I'm talking about here are just kind of those single element sort of approaches and mostly focused on the below ground activity here because the science just in terms of where the market can interface really isn't far enough along on the non-CO2 sides and some of the air quality things. So starting out here, and I know you guys probably can't read all these various descriptions, but the point to highlight here, this is a report done by the California Environmental Associates in 2012. It was a report to the Packard Foundation, which has been a really great funder in this space, not just of biochar specifically, but looking at how agriculture can contribute to climate change mitigation. And they're increasingly working in international contexts on indirect land use change, biofuels, and so forth. So CEA synthesized some research that was done by a group called TIAG, which is based out of Duke. They're no longer really active, but they did a series of reports in 2009 to 12. And this is based on a survey of literature where they looked at all the mitigation opportunities, they called them, in metric tons of CO2 equivalent per hectare per year terms. And what they found is that even though there's a double asterisk saying that practices are based on data with significant research gaps, biochar applications to croplands in the US came out way on top. 10.1 metric tons of CO2e per hectare per year. And if applied to all 124 million hectares in the US for cropland, that would be approximately equal to all U.S. industrial sector emissions. So it's a bold claim. So we have to kind of unpack this a little bit because there's been a lot of talk about, and I work on fertilizer N2O emission reductions in the Midwest. Those are pretty small margins. And so to see something, you have an opportunity to go 5, 10 tons, and you only have a fraction of a ton on N2O, seems almost too good to be true. So what is the state of the science with respect to greenhouse gases? USDA just last week, I'm not sure if it's really made the rounds yet in the PR circuit. It's kind of a boring title. It's Quantifying Greenhouse Gas Fluxes in Agriculture and Forestry, Methods for Entity Scale Inventory. And this came out of the Climate Change Program Office, which is part of the Office of the Chief Economist at USDA. And the 2008 Farm Bill directed CCPO to look at what the state of the science was and how USDA could help kind of settle some debates or clarify where the scientific community was at with respect to all these agricultural and forestry mitigation options. And what they found, it's a 606-page report, and there are about 5 paragraphs on biochar. So it made it in, but there's no quantification methodology. They basically said it holds a lot of promise, but we don't know how to translate short-term lab or field studies into long-term or generalizable methodologies, which I thought was a reasonable conclusion. And especially given the remarks from this morning, I don't think we're there yet. There's also another meta-analysis that a guy that I've worked with a bit in the greenhouse gas space, Noel Gerwick, was the lead author that came out in September in PLOS One. And he tried to look at, he looked at 311 studies, peer-reviewed studies from dawn of time, I guess. I guess the first study was in the 70s, up through January 2012. And he boiled it down, and you can see the bar chart here, and basically only found 7 real field studies about in situ biochar decomposition. Because that's really the critical claim in greenhouse gas markets, is how stable is biochar, how reliably can we look at its effects in soil. And then on nutrient loss, I should also add, that's the one on the far right. I wish I had a pointer. That's only one field study. Oh, I do? Oh, sure. Okay. Oh, I must have covered it up.
Yeah, here you go.
Excellent.
Top button there is a pointer.
Thank you so much. Cool. I've never used one of these before in a talk. I'll try not to abuse it. So you can see that most of them are over here on production analysis, and that's all important stuff. But Noel and his author team basically said, we don't know enough to draw real sharp conclusions or strong conclusions about this. And he also only found about 4 or 5 LCA studies, because that's also really important, is looking at the whole greenhouse gas budget of biochar, not just what it does below ground in soil. So, with that said, the caveat to proceed with caution, the American Carbon Registry, which is a subsidiary of Winrock International, had a methodology for biochar projects that was released in draft form last September. It's expected to be finalized this December. There's been a lot of debate within the scientific community about decomposition and testing methods and different things. But I would encourage you all to check out this methodology. It's available for free online just at americancarbonregistry.org. They're a small staff. They're spread all over the country. They're really great to work with. So there's a multi-author team, and they started in about 2010. And it was by this guy named Keith Driver, who's based in Alberta. And he and a consultant, John Gaunt, put their heads together and they said, what does biochar look like if we turn it into a carbon credit methodology? And then they pulled in the Climate Trust, which is a Portland-based nonprofit, and also some folks from the Prasino Group, which have done a lot of work in the dairy sector and some other manure digestion methodologies. And then also Debbie Reed and Stefan Yurka from the International Biochar Initiative. And they wrote this, it's 130 pages or so. Most of it is kind of methods just being broken down by variables and appendices. So it's actually fairly readable. And it's a nice sort of synthesis of how you can start quantifying this stuff. The feedstocks are focused on ag and forestry residue. They also include municipal solid waste and other feedstocks that would meet the IBI, the International Biochar Initiative product standards, which came out last spring. So the default baseline is fairly conservative, but it's interesting. It's basically saying it would have been what feedstock would have otherwise been combusted for bioenergy production. So that means that it leaves avoided methane generation, electricity, biooil, heat, all that stuff off the table. So if you want to do the alternate baseline, which I'll show in a second, the burden of proof is on you, on the project developer. Otherwise, it's saying it would have gone to combustion. And basically, project emissions equal the direct emissions from the project, from the pyrolysis, plus auxiliary stuff like electricity use, minus, so it's a net of the carbon sequestration. So I'll unpack all 3 of those. And then the emission reduction credits are just baseline minus project minus leakage, which in this case would be efficiency losses in the pyrolysis process. And then there's a 7-year crediting period. So if you start a project in 2015, it would go through 2022. So apologies here as well. This is kind of hard to read, but boundary conditions are very, very important in greenhouse gas projects. And so this just kind of highlights the process flow about that alternative baseline that I mentioned, where it includes aerobic decomposition, combustion of feedstock, fossil oil use, et cetera, et cetera. But the focus here is on soil amendment and applications of biochar in the U.S. and worldwide as soil amendments. So you add all these things up, that's your baseline. Then for project emissions, note the dotted lines here, which I can't quite get all the way around, there, and that's what counts. So there are some intermediate things like transportation and the tractor use or something that aren't included in project emissions, but it is a comprehensive calculation here. So you add all those things up, then you get your project emissions. And I'm happy to go back in any of this stuff with questions or unpack other parts of the methodology, but I'm just trying to skip through in the interest of time here. So in terms of quantifying the carbon sequestration, and Wade did a great job of showing what was happening there, and he showed the curve about the decomposition. So that Lehman study is also cited in this work. But what's interesting here is that they set a rule that the hydrogen to organic carbon ratio has to be less than or equal to 0.7. If it's above that, there's a spectrum of black carbon. They say it's not biochar. And then also, there's some conservativeness built in here because basically, you're not going to get more than 50% of the biochar carbon credited. And if it's 0.4, you can get 70%, but that's it. So it can be less than the hydrogen to organic carbon ratio can be less than 0.4, but it would still be at 70%. And so what you basically do here to get carbon sequestration is you take the mass applied and then the organic carbon ratio and the percent that breaks down over 100 years, and then factor in the moisture content and the molecular ratio of CO2 to C. And then there's a correction factor right here, the 0.95 for some other losses. So that's the carbon market side. Now on water quality, it's much trickier. And actually, I couldn't really even find a good study on it. And as I mentioned with the Gerwick study, there was really only one field study that they found. But there is the startup company Cool Planet, which some of you may be familiar with. They've done some limited field trials. This is one from a winery in California, where they did find that control versus a biochar application, there were some benefits. And some numbers have been thrown around. There was another lettuce field trial that they did. It's a 40% nitrogen loss reduction. But we don't really know. And so we need to look at these things and get the entrepreneurial community engaged in field trials that we can defend in the scientific peer review community in the journals, and then start looking at them, and then at that point see if we can incorporate them into like the Illinois nutrient loss reduction strategy, which is going to be coming out this fall. Doesn't even mention biochar, let alone compost. I also checked the Iowa one that was published a year ago or so, a year and a half ago, and they do mention compost as having some promise. So there's possibility that you could have some soil amendments factor in to nutrient loss reduction strategies that are submitted to EPA for their compliance in the Clean Water Act. But we're not really there yet. And the other question is, in the meantime, who pays? We don't really know. We had to engage the point source community and convince them that if we can't do this as a regulatory process, or other people, if there are water quality benefits, is there a way of, kind of avoiding the Toledo disaster of last weekend? If biochar can help stabilize that or somehow reduce the nutrient losses that are contributing to those downstream problems, hopefully there's a willingness by the point source community, drinking water, waste treatment plants, to pay for that. But they need to be convinced that it's going to work. So that's all I have for now. Happy to answer questions.